This conference will now be recorded.
Okay. Good morning, friends. So in today's session, we are going to talk about Spark SQL execution plan. So we already discussed it's nothing but a catalyst optimizer, what we are going to discuss. Okay. Anybody remember as part of our training, we already discussed this catalyst optimizer. What is the use of this catalyst optimizer? How we are going to use this? Anybody remember, friends?
So it will generate the optimized execution plan.
Okay, it generates the optimized execution plan. What else?
We have a different kinds of plans like unresolved plan, logical plan, optimized plan, physical plans.
Very good. Exactly. So what is unresolved logical plan? So what is logical plan? What is physical plan? How the Spark is going to optimize in backend? So what Spark is doing in backend will be able to see. Can we go and look at what exactly the steps that Spark is doing? So yes, we can do each and everything. So let me first explain Spark SQL execution plan. Then we will talk about the each phase that we have in the entire execution plan. Once we understand the execution plan, I have taken some examples that I'll show you in the slides. Then we will go to the lab. In lab, we will try to understand each and everything. I just have written very simple program. So in our, as part of our training, I have given different example. Now I am going to give you some more examples so that you will have a 2 example in handy. Okay, fine. Let's move on. So now first let's try to understand. See, this is the SQL query we are basically submitting. Okay. So basically Spark SQL, I have written a SQL query and I am submitting. Maybe user also can create a data frame. That data frame user may create from the any CSV file or any Parquet file, any file, right? So maybe with some sample data also we can able to create the data frame. So what is going to happen when you create a data frame SQL query? So if you remember, Spark is lazy evaluation or not? Spark is lazy evaluation or not?
Yes.
Okay. So, okay. So let me go and show you. Is it really Spark is a lazy evaluation or not? Let's see. Okay. So R1 equal to sc dot text file. So I'm trying to create a text file from a path which is not there. Okay. Cloud Pandit slash Cloud Pandit slash Cloud Pandit. Okay. So you know this path was not existed. So but I'll not get any error. Okay. So I can also apply some transformation on top of it. So lambda x equal to x dot split. Okay. Maybe this you can say R2. Okay. Now execute this, you won't get any error. But even though you have not having the file, you are not getting any error. So what is happening now? Because Spark is a lazy evaluation, that's why Spark is not able to return. Spark is not able to return my data, something like this. Write it, anything you write it, but it is not giving any error. What is this collect? Anybody have any collect or count? What it is?
Action.
What it is? Action. So what is lazy evaluation? Lazy evaluation meaning when you apply transformation, when you apply
Action.
action, then transformation will execute. Transformations will not get executed until you apply action. Let's see when you execute this. So we are clearly seeing it is saying now input path does not exist. But why it did not check at this point? Why it did not check at this point? Why it did not check this at this point is because Spark is a lazy evaluation. Spark is a lazy evaluation. Okay. So now give me 1 minute. Sorry. So let's say same thing. Okay, same thing. I'll try to create with the data frames. Spark dot read dot format of CSV dot maybe as you used to use the option, though you can use some options like header equal to true if you do some file. Okay, now let's try to execute. So can you tell me, will it throw error or not? Please respond.
Yes, it will throw.
Why it will throw error? It is Spark is lazy evaluation, right? It's a transformation. Why it is throwing error if the path is not available? Any idea?
Yeah, catalyst optimizer try to generate the execution plan.
Okay, so that is what we are going to understand. What is happening in the data frames? What is happening when you create these, when you submit Spark SQL, when you are creating data sets? So if you are using other than Python, you know, we can also create data sets. Okay, so now we are going to understand when you creating the data frame data set as Spark SQL query, when you are submitting, it will throw error immediately. Why? Okay, let me show you first. It will throw error. See, path must be absolute. Okay, path must be absolute. Something like this, it will clearly telling you this particular path does not exist. Path does not exist, it is saying now. Okay, meaning it is clearly saying this path is not available. Why? What is happening in the background is, that is what we will discuss now. Let's say I am trying to create a data frame. You just have seen I got an error immediately, even though Spark is lazy evaluation. Similarly, when you apply Spark SQL query, so similar, let me show you that also, because anything that we are doing, let me show you practically so that you'll have some understanding. df equal to spark.sql. See, select current underscore date. If I want, I'll get it. It's a function. Okay, let's say I'll say something like this: select a star from table. Table is, let's say, Cloud Pandit. Cloud Pandit, the table is not there. Let's see. This clearly saying table or view not found. Immediately it is throwing error. If it is a transformation, it should not execute, but it is throwing error. What is happening? When you submit a SQL query or data frame, this is called a front end. From front end user, we are submitting the query. When we submit the query, first there will be a plan. Okay, Spark will create some plan. That plan is nothing but a unresolved logical plan. So what is meant by unresolved logical plan? Unresolved means for a problem we did not get any solution yet. We are still checking. Okay, so now you have given a path to read a file. So we are not sure at this time. At this time, we are not sure whether this path is available or not. Similarly, when you are writing a SQL query, in the SQL query, select customer ID, customer name from customer table. Cust is a table. We don't know whether cust table is available or not. Under that cust table, CID, CNAME, these two columns are available or not also, we don't know. So that's why, as we don't know anything, that's why the first plan, whatever we are creating, is unresolved logical plan. So from unresolved logical plan, when we have a problem, when there is no solution, what you will do? You are going to check for the solution. Okay, you are going to try to get the solution. That is what from unresolved logical plan. In the unresolved logical plan, what it is going to do immediately is, there is a schema catalog. Schema catalog meaning there will be metadata information. Enter metadata, the paths, or you can say table information, or you have column information, everything will be stored. Okay, that schema catalog will be there. So basically, mostly we won't to try to customize anything in the schema catalog. Okay, but I heard about some project people are trying to do some customization even in the schema catalog. Okay, basically what is going to happen in the schema catalog is, our metadata catalog, it will have complete information. Okay, it will have complete information like tables, paths, columns that are there in each table, everything. So unresolved logical plan, if this particular plan needs to get the solution, what it has to do is, it has to go to schema catalog and it has to check everything, whether everything is there. Okay, let's say in schema catalog everything is there, then schema catalog will tell you, okay, everything is there. So then unresolved logical plan will tell you, okay, everything is there, whatever we need. So then create a logical plan. So now You have a logical plan. Logical plan meaning, so whatever paths you are mentioning, whatever tables, columns you are mentioning, everything is fine. Everything you have, you don't need to worry about it. That is the first unresolved logical plan. In unresolved logical plan, we will not know whether tables, paths are available or not. We are going to the schema catalog and we will verify everything is there. If everything is there, we will create a logical plan saying that everything is available. If everything, any of this is missing, we will immediately throw error. That is what we have seen clearly now. All of you clear till here? All of you clear till here? Okay. Now, in logical plan, so in logical plan, what is going to happen is, in logical plan, some kind of a typecasting. Okay, so necessary typecasting, necessary filter checks, all those things. Sorry, filter checks, all those things will be verified in the optimize the logical plan. In logical plan, necessary typecasting and partitioning, those things will be done under a logical plan. In logical plan, what is going to happen is, example, let's imagine you are doing a join between the two columns. Okay, customer ID and sorry, store ID and store location ID, something like that. Okay, so now store location ID in a location table and store ID in the store table, both are a foreign key relation. Okay, now what you wanted to do is make sure store ID and store location ID, these two columns are having the same data type. Okay, so one is integer, one is long. No, like let's try to make it as a both are long or both are integer. So such type of necessary typecasting will be taken care by logical plan. So after logical plan, we have an optimized logical plan. In optimized logical plan, so there is a lot of optimization is going to happen. So how? So there is a set of rules Spark already have created. So based on those rules, which transformation we need to execute first, which transformation we need to execute second. So which one we see, that's why lazy evaluation advantage is, so once it is the lazy evaluation advantage is, once it understand all the transformations that you have applied on a particular data, it will just reorder those transformations. Example, you are first reading the two files, then you are joining, then you are filtering. So can you tell me what is the optimization we can do in this example? Simple. There is in all the store data, I have store locations data. Now I joined these two tables. Later I am filtering only store location equal to US. After joining, I am just filtering where store location equal to US, and then I am showing the data. What optimization can be done in this?
So first, if we apply the filter, then we have a small result set. So on top of
Exactly.
it,
Exactly. So we need to filter out the location, store location equal to US. If we filter out at the beginning itself, while we are joining, we can join with a very less data. So you only US store information we can take and we can join. It will basically optimize overall performance. Understood? Okay, so such type of all the optimization, okay, rule based optimization, path based optimization. So there are different optimizations will be there. So all those optimizations it will apply and it creates the, so this is the basically catalyst optimizer job. Okay, this is the catalyst optimizer job. Now once the optimized logical plan is created, from this optimized logical plan there will be a multiple physical plans. Okay, this we can able to execute in this way, we can able to execute in this way, we can able to execute in this way. Different plans will be created. Okay, maybe what you can do is, so you have stores data and the store location, you are basically joining and you are filtering. Okay, you are basically joining and you are filtering. If there is no filter, so whether you are applying filter front or later, we don't have any problem. Okay, sorry, if you don't have any filter, so we no need to apply that filter, meaning whether we are doing transformation. Example, I want to add a extra column on top of the data. But extra column, when you are when you are adding that extra column, mostly even if you do little bit early also, what is going to happen is it is going to check whether derived column, whether he is taking after the joining or not. Maybe you derived some column, you are not taking it forward, okay, meaning you are not, after joining you are not selecting that column whatever you derived. In that case, basically whether you are deriving that before join or after join doesn't matter, okay, doesn't matter. So meaning, so it is basically based on the transformations that you have created, it will create a different physical plan, what all you can able to do. So these are the different approaches that you can able to execute your entire code. This is a physical plan it will create. But out of this, we are not going to select anything. Again, from out of these multiple ways of executing our Spark code, Spark itself understand different parameters. One of the parameters is cost. Okay, it is going to estimate, okay, how much cost it is taking. Second parameter will check, so how much compute, how much time it is taking, how many resources it is taking. So all these checkings, all these parameters, it is going to verify on each physical plan. So on each physical plan, it is going to estimate what is the cost, how much compute it is using, like how much time it is taking. So all those things it is going to verify from this cost model, and all based on all these parameters, it select the best physical plan which it can able to execute to reduce the cost, to give the better performance in a less time. So once it is created the physical plan, okay, so first read, filter, join. So this is the order it has selected. That particular order of data frame logics will be converted into RDD. It will be converted from higher level to lower level object, like you know, right? So whatever English terminology, whatever we are writing, that will be end of the day converted into zeros and ones, and system will execute it. Similarly, here RDD is the low level object. So what happens, whatever you are creating on top of it, like D streams, vectors, or data frames, data sets, all these things, it will be end of the day converted into RDD. RDDs will get executed. Okay, so this is nothing but a backend what is going to happen. Any questions in this?
Yeah, Malaya. So I read one article, like in the article it was mentioned, like, the optimized plan will be taken care by only the catalyst optimizer. For the unresolved and the logical plan will be taken care by the other components like parser and analyzer, like that they have mentioned. Whether that is correct or?
All these are the components of the catalyst optimizer. Okay, so optimizing meaning they are just looking at the optimized logical plan only, but all these are the steps within the catalyst optimizer.
Okay, they have mentioned, like, the catalyst optimizer will be taken care by only for generating the optimized, optimized logical plan. The parser will be taken care of the unresolved logical plan, and analyzer, I think something analyzer will taken care of the logical plan, like that they have mentioned.
See, that is, you are totally confused. See, you should not say that they have written like that. Their understanding is they are trying to tell you something. Unresolved logical plan, also called as a partial logical plan. So there are some terminology, so that I have put it in the chart, in the PPT, you will be able to see. So basically, so unresolved logical plan, you can also call it as the partial logical plan. Okay, that doesn't mean that unresolved logical plan will be done by partial logical plan. No. So unresolved logical plan, you can also call it as a partial logical plan. Similarly, a resolved logical plan, or you can say logical plan, you can call it as a resolved logical plan or analyzed logical plan. Those are the different names they have. They are trying to tell you. You can say unresolved logical plan, or you can say partial logical plan. Next, you can say logical plan, or analyzed logical plan, or resolved logical plan. All these are the naming convention. That's all. So for the optimized logical plan, only one name, that is optimized logical plan. Okay.
Okay. So once the optimized plan has been generated, right? So who will like which component will be generates the physical plan?
Physical plan, who will be created? So physical plan will be generated by Spark. Catalyst optimizer, till optimizing these particular things will be taken care by the Catalyst optimizer. After that, Spark job itself, it will take care of.
We don't have a separate component.
No, we don't have any separate component.
Okay.
Spark
Thanks.
itself will estimate all these things and it generates the RDD.
Okay, got it.
Any other questions, friends? Fine, let's move on. So now I think let's let me quickly discuss the this thing PPT, then we can move on. So you can see here also this is similar. Okay, maybe you have Hive query, SQL query, data frames or data sets, anything. So that is basically unresolved logical plan. Or see, this is a analysis rule. Analysis rule meaning that is the just a meaning. That is just a meaning. Analysis rule meaning it is good. Here analysis is going to happen, but you see here this entire thing is going to happen where under Catalyst optimizer. Are you seeing this? So I think you are talking about this analysis rule. So what is this analysis rule? Meaning all the analysis, whether in the schema catalog, all these things are there or not, that analysis will be done as part of this unresolved logical plan. If everything is there, then we will come to the logical plan. In logical plan, so all the required typecasting, everything will be done as I mentioned. Then so it will apply the optimization rules on top of this logical plan to generate the optimized logical plan. From there, it creates the multiple physical plans. From multiple physical plans, it generates one or more physical plans using the physical operators that match the Spark execution engine. See, so who is going to create these physical plans? So Spark execution engine will match the physical operators and it will try to create by Spark itself. Okay, then selects a plan using the cost model, and cost model meaning how much resources, how much time it is taking, how much cost. Based on that, best physical plan it will select. So selected physical plan, it will with the selected physical plan in that order, the RDD code will be generated, which means this phase involves the generating the Java bytecode to run on each mission. So as we mentioned, so we need to run on the mission, so we need to generate the low level objects. So that is what is going to happen in the background. Clear? Next. So when we create a data frame dataset SQL query, now the first step will be generation of the logical plan. That is nothing but a unresolved logical plan. So this unresolved logical, so I think this point tells you overall unresolved logical and optimized logical plan. Okay, so this entire logical plan is divided into three parts. One is unresolved logical plan or partial logical plan, or resolved logical plan, or analyzed logical plan, or you can call it as a logical plan. Any name you can use. Okay, then the third one is optimized logical plan. These are the naming convention. You can see if somebody is talking about this is called a partial logical plan, don't think that it's a different. It's a simple unresolved logical plan only. If somebody talk about resolved logical plan or analyzed logical plan or logical plan, that is nothing but a same. So here if you see unresolved logical plan, the resolved logical plan, meaning all the tables, path, columns, whatever, everything is available. Here you do the necessary typecasting, everything, and create the optimized logical plan. Clear? So let's imagine this is some example. Okay, what we have taken from the Databricks documentation. In the Databricks documentation, you can see, so there is a two tables I'm scanning. Okay, scan table 1, scan table 2, then he is joining, then he is applying the filter. Okay, then he is applying the filter where t2.id greater than 50 into some 1000. Okay, some 50,000. So where ID is greater than 50,000, meaning first 50,000 records he don't want. He is just filtering out the records which are more than 50,000. ID which is having more than 50,000 value, only such type of data we need. So project meaning you are going to select what columns you need. Okay. So what is this aggregate? The aggregate is nothing but a sum. Okay, any sum of the values, whatever you are doing, you can see here. The sum of V means it's a aggregation. When you are selecting any particular column, that is nothing but a projection. Okay, if you are applying any filter, see where is basically mentions the filter. But in Spark, you know, filter or where are the alias names, you can use any name. Okay, filter you can use or where you can use. In SQL, basically only where we will use, but with the data frames you can use df.filter or df.where, you can use any of that. So join is nothing but here you can see. So T1 and T2 tables we are scanning here. What we can do, what optimization we can able to do, let me show you that. So as you just have seen, before transformation it looks like this. Okay, so when you apply all the transformation, when you submit it, Spark Catalyst Optimizer will do this kind of optimization. What it will do, it will scan T1 data, it scans T2 data, it selects whatever columns you need from the table one. It is not going to take all the columns that you need. No, maybe after joining you are selecting only few records. Then what it will do is, why I need to read all the columns, and when he is joining I need to, like when he is selecting, only filter out whatever columns user required. Instead of that, while scanning the data itself, let me scan only these two columns. Okay, so what it will do is, even though 100 columns you have in table one, but you are selecting only these two columns on after the join. So after the transformation, all transformation only execution will start, right? So now what happens is, it scans the data, and it selects whatever columns you need. Similarly, table 2 also it scans and it selects whatever columns you need. Then on the table 2, there is a filter applied in the SQL query. If you remember earlier I have shown you. So it just to tell you T2.id greater than 50,000. See, all this calculation also it has done greater than 50,000. So greater than 50,000 records, whatever result you have here, these two columns result, whatever you have with that data, it is going to join. Then after join, so you know we are basically using these three columns only for calculating some other columns also. So it will just take these three columns, and on top of it, if we have any aggregations, it will do the aggregate function. Now I want to resolve some issue. Many people will confuse a lot. So one time I said Spark is lazy evaluation, but when we executed the data frame, it has thrown error at the beginning. Again, here I am coming and telling you, so Spark is lazy evaluation. So you can see all the transformation once I apply, then only then it will understand, okay, what columns you selected. So those columns it will select. Okay, it will scan data and it will understand what columns you need. It is going to project only those columns, and so on. I'm saying. So everybody understood, because it's a confusing, right? How many of you confused here? I just wanted to clarify. I'll give you more clarity on this if you confused, but if you understood, then that will be good. See, first thing is, everybody understood what I asked now. Tell me how many of you not understood what I asked now. See, don't mind in asking the question. I know I'll explain, okay? You don't worry, ask. See, question is very simple. Question is, in RDD, we have seen it's a lazy evaluation. We can clearly able to see. So when it is a lazy evaluation, what happens is, you will know all the transformations will be weighted until you apply action. When you apply action, Spark can do the optimization, because it knows what all transformation it has to execute. We have seen reading, map, filter, and collect. Now, meaning you have three transformation: reading, map, and filter. So out of these three transformation, what optimization Spark can able to do, it will do. Okay, what optimization Spark can do, it will do. Understood? But now the question is, in the data frames, when we have read the data first time, so it is not waiting until you apply action, it is immediately throwing error. In this case, how it can do the all optimization? Maybe in third transformation, I am selecting the two columns, but it is reading at the first time itself, it is reading all the columns, right? So transformation 1 is reading the data, transformation 2 is filtering the data, transformation 3 is something else, selecting the only two columns out of 10 columns. But how Spark is at the first step itself reading only two columns, which I applied at the third step, in the third transformation. Everybody understood? In data frames, reading the data, filtering, selecting the 2 columns. These are 3 transformation I am executing individually. But how Spark data frame can do this kind of optimization? So third level, I have applied the what columns I need. How it will know at the first step itself? Any answer for this? So first tell me simple question. Data frame is a lazy evaluation or not?
Looks like it is not lazy evaluation as per our scenario which we saw there, from my understanding.
Good. Remember, data frame is also a lazy evaluation only. It will not compute the your transformation until you apply action. Why it is throwing the basic things? It will because data frame is it imports the structure of data into the data frame. So that's why it just read one record. If you remember, I have shown you that we discussed that, right? So jobs, stages, tasks, how it is creating jobs. So when it is creating the job, if you directly Spark.read that format of csv.option header equal to .load, when you do, it basically reading one record, but it is creating one job and it is reading the one record. But if you provide user defined schema, it is not looking at your data at all. It is not creating any job. Did you remember that session? When you define user defined schema, it is not looking for any data. It is not touching your data, meaning it's a lazy evaluation. Why it is touching your data and reading one record when you are not defining the user defined schema is data frame is having the catalyst optimizer, which is basically going to validate all these things. Okay, which is going to validate all these things, but the actual execution will not happen. Okay, so catalyst optimizer is going to validate all the paths or tables, columns are available or not. That's why only one record, even if you have billions of records, only one record it will read and it will check the paths, everything is available or not. That clearly, practically I have shown you. How many of you remember, friends? Can you just tell me, speak or tell me how many of you remember? Why nobody is speaking? Siddesh, okay, good. Clear? Fine. So now let's see lab. So these all things I already discussed, but theory, if we discuss much, there is no use. So unresolved logical plan, I'll quickly discuss. Okay, unresolved logical plan. What happens when we submit code? It is valid and the syntax is also correct. So there are 2 errors you need to see. If the syntax is also error, you will get immediately error. Okay? So that you will get it even in audit, not a problem. But the column names or the table names may be inaccurate or may not even exist. That's why we call it as an unresolved logical plan, which means that maybe the table is already existed, but you have given incorrect name. Okay, incorrect name meaning the table name is customers. You have given customers is there, but you have given customer. Okay, so that is the inaccurate, like incorrect name you have given. So with that name, if you go and check, that may not be existed. Okay, so that's why it may not be there. So we don't know whether these are available or not. That's why this plan is nothing but an unresolved logical. When we give a wrong column name, or our unresolved logical plan is still created. When we give a wrong column name or wrong table name or wrong path, our unresolved logical plan is still created, because this is the first step where Spark has created a blank logical plan where there are no checks for the column name, table names, file paths, etc. If the analyzer is not able to resolve them, resolve them, column name, table name, extra, it can reject our unresolved logical plan. So what is going to happen here? What is going to happen as part of the catalyst optimizer? We are going to the schema catalog and we are going to analyze. Analyze whether all these columns are available or not, all these tables are available or not, paths are available or not. So all this analysis we are doing, Okay, if it is not there, then we are rejecting our unresolved logical plan. If it is there, then we are creating the resolved logical plan. We are creating the resolved logical plan. So resolved logical plan, also call it as a logical plan, unresolved resolved logical plan, or logical plan, or one more name I mentioned, I didn't remember. Okay, if the analyzer is not able to resolve them, column name, table name, it can reject our unresolved logical plan. But if it gets resolved, then it creates a resolved logical plan. Necessary typecasting will be done as part of the logical plan. Next, optimize the logical plan. In Catalyst Optimizer, which will apply its own rules and will try to optimize the plan. Basically, Catalyst Optimizer performs logical optimization. So all the, as we discussed, filters, pushing the filters and all those things, kind of here some optimization it will do. And we also have something called broadcast join. So based on the configuration, if your data frame data is very small, okay, it will broadcast it automatically. Spark will broadcast it automatically. What is broadcasting? We'll talk about it. Okay. So it checks for all the tasks which can be performed and computed together in a one stage. So optimized logical plan, it checks for all the tasks which can be performed and computed together in a one stage. So when new stage will create it?
When there is wide transformation.
When there is
Shuffle.
when there is a wide transformation like join, group by, all these things, new stage will get created. In a multi-join query, it decides the order of execution of query for better performance. So we also discussed this multi-join query. Let's say there is an inner join. Okay, I have to do the inner join between three tables. Total 3 tables I have. Okay, so table 1 is having 1 billion records. Let's say 100 million records. Table 2 is having 10 million records. Table 3 is having just a 10,000 records. Okay, so 10,000 records. Now, what is going to happen is, if you join the unresolved, like if you are joining the 100 million records with the 10 million records, it result, even if everything is matching, it result how many records?
Records only.
Sorry. So now 10 million records are there. Sorry, 100 million, 10 million, then 10,000 records. So if you join, just imagine if you join 100 million records with the 10 million records, the result is again a 10 million records, meaning lot of data you are comparing. Can we avoid something? Yes. The order, if we change like 100 million records, if we join with the 10,000, the result will be only 10,000. So these 10,000 we can join with the 10 million. So this will basically reduce the number of comparisons or the number of matchings within the worker nodes. Okay, so such type of optimization you can able to do in the multi-join query as well. Clear? So tries to optimize the query by evaluating the filter clause before any project. This in turn generates the optimized logical plan. We just have talked about this one. Okay, physical plan. Optimized logical plan is created, then further physical plan is generated. Okay, it simply specify how our logical plan is going to be executed on the cluster. So physical plan is nothing but how this is going to execute on the cluster. It generates different kinds of execution strategies or plans, then keeps comparing them in the cost model. For example, it estimates the execution time, resources to be taken by each strategy. Finally, whichever plan strategy is going to be the best optimal one, it selects the best physical plan or selected physical plan. So let's say we are performing a join query between two tables. In that join operation, we may have a big table and a small table with a different number of partitions in different nodes across the cluster. Then what it will do, Spark decides which partition should be joined first. Basically, it decides the order of joining the partitions, the type of join, extra for better optimization. As I mentioned, we have something called broadcast join, we have sort merge join instead of shuffle hash join. So there are different sorting join methodologies which it follows internally. Left join, inner join, right join, that is different. Okay, so how these joins are going to be done internally, for that there are different join plans. Okay, so like there is something called broadcast join. Broadcast join meaning so what happens if you have two people, there are different chocolates with them, you need to ask them to compare it, just match which chocolates are matching. So these two people are matching, right? Similarly, so what optimization you can do is, if you have multiple people, instead of moving the chocolates from one mission to another mission, what you people can able to do very simply is, if the chocolate count is very less, you put all the chocolates in with all the people. Okay, let's say I have a chocolate packet and I have a 5 chocolates. Then what you can do is, instead of splitting these 5 chocolates to everybody and asking them to compare with the packets that they have, I have a 5 people, so everybody is having the chocolate packet. Now I'm giving 5 chocolates to these people, and these people what these people has to do is, first person take a first chocolate, he compared with all the chocolate packet. Second person take a second chocolate, he will compare with all the chocolate packets, and so on. First, this iteration is completed, first person take the second chocolate and compares with all the chocolate packet. Got it? This example, everybody understood. See, 5 people, 5 chocolate packets they have. So I need to compare with only 5 chocolates individual I have. I need to check their color, the color of the chocolate. So simple. So first chocolate, give it to the first person. Second chocolate, give it to second person. Third to third, fourth to fourth, fifth to fifth person. Now they compared, they understood, okay, these are the matching with respect to the first. These are the matching with the second. Now first person only compared with the first chocolate. He still has to compare with the 4 more. So again, in second iteration, first person takes the second chocolate, second person takes the first chocolate, something like that. They will exchange, understood? So when that exchange is happening in the network, there is a lot of problem. Okay, a lot of performance issues will come. So what you can do is, as you have only 5 chocolates, give these 5 chocolates, all 5 chocolates to the first person, all 5 chocolates to the second person, all 5 chocolates to 3, 4, 5, fifth person. All you can give at once, meaning we are going to cache it. Broadcast join means small data frame, we are going to cache it in the worker nodes, so that it will be there in all the worker nodes. There is no movement in the data. We can avoid the data movement within the network, which basically give the better performance. Okay, because everybody is having 5 chocolates within each mission, it can compare. You don't need to move the small data frames or data from one mission to another mission. Okay, that's all, friends. Any questions? So we will move on to the lab now. Anybody have any questions? Please confirm quickly. We can move on to the practicals. Sudha, Balaji, Sharath, Ramireddy, Pavani, Naresh, are you full clear? Venkat. Okay, fine. Let's move on. Fine. What we'll do now, let's come here. Till here we executed. Okay. So now I have 2 things. Okay, you see here, I have a store location. Okay, these are the store locations. What I have: India, US, UK, Pakistan. And I have a stores information, store ID, store name, store operation, store location, store owner, store profits. Okay, these are the some of the data that I have. Okay, now come here. I want to upload those 2 files. Okay, go to data, create table, browse it, and data sets. So I just uploaded these 2 files. You can see file store / table / store for.csv, store location for.csv. Basically, the name of the notebook I forgot to change. 1 second. So is all this. So whenever you are reading the file, so try to read in a schema, like define the schema and try to read it. This is what we discussed. Okay, so this particular data frame we read, let's say I want to display this data. What data we read it? Let's see that. See, this is the data that I have. Okay, clear. Store ID, store name, store open year, store location ID, store owner, store profit. Now let's read the store locations. df underscore store locations. I am trying to read it. Okay. See, store location ID, store location. So 100 India, 200 US, 300 UK, 400 Pakistan, something like this. Store locations I have. So you know this is the store locations. This is the stores information. What is the common in between these two? If you look at here, so store location ID is here. Store location ID will be there here also. Okay. So I want to join these two data frames to get a store location. See, example, the store Rama store was opened in which location? I don't know. It is opened in 2000, but it is located in which location? I don't know. I want to get that information. If you want to get that information, you need to join. Okay. Let's say df store. Okay, alias store. That join. I want to join with a df store location. That is a location. Call of store.store location ID equal to location dot store location ID. Okay, it's a inner join. It's a inner join. Cleared all of you? It's a inner join. All of you clear on this? Okay, this is a store table. I want to join with the location. Okay, so store location ID is equal to the location table dot location ID. It's an inner join. So this join is a wide transformation or narrow transformation? Wide transformation. When it's the wide transformation, what is going to happen is data shuffling will happen, isn't it? Because we just discussed when you join, you need to join with the matching chocolates, meaning there will be a movement in the data as we are not using any broadcast. But in the latest Databricks runtimes, what is happening is by default, so if there is a parameter, okay, so what happens is, let me show you. Default broadcast size, broadcast join size in Spark. Okay, execute this. So what it is saying, 10 MB. Spark also internally maintains a threshold of the table size to automatically apply broadcast join, meaning as we are dealing with the small data. Okay, try to understand. As we are dealing with a small data, what it is going to do is it is going to keep this particular data in the memory when you join, because it will try to use the in memory. Everybody understood? It will try to use the in memory. All of you clear on this? Okay, it will try to use the in memory. So why it is using in memory? Because as the volume of the data is small, it is going to keep this particular data in all the missions. So data will not be moved. Entire data will be there in all the missions that we have. So that's why it uses the in-memory scanning. In-memory scanning means automatically it will be cached into the memory. Next time, whenever we want, it is basically going to scan it from the memory. That you can able to see in the execution plan. What happened in the background when we are looking at, you will be able to see. So I'm adding a one column here. Is closed. The store is closed. A store location equal to yours, then closed. Otherwise, it's a active store. So then group by store location. So in India, all the store locations you group by all the India stores you take and tell me the overall profit from the India stores, overall profit from US stores, overall profit from UK stores, and so on. You can able to get this information. Clear? Let's execute this. You know what you are going to get it. So for each country, so for India, what is the profit? 12,000. For US, what is the profit? 8,000. For Pakistan, what is the profit? You can say 7,000 profits. Clear? Now this is the DF store location. Stores and location both I have. So I want to basically explain. I want to get the how this execution happened. So you know, as part of our training also we discussed, explain will give you only the physical plan. So out of unresolved, resolved, optimized logical plan and physical plan, out of these four, it is basically going to give you only physical plan. What are the four plans? unresolved logical plan, resolved logical plan, optimized logical plan, then we have physical plan. But if you simply explain, it will give you only physical plan. It will give you only physical plan, what happened. Okay, let's try to understand what happened. See, in memory file indexing. Okay, in memory file indexing, meaning, so all these files it is trying to read it from the in memory. Okay, remember. Next thing is pushed filters. So this is very important, friends. Remember, this is in interview also people will ask you. Pushed filters means, you can say this is called a push down filters. Push down filters, what happens is if you apply any filters on the data, right? While reading the data itself, it will filter the data and it will read only the data which satisfy that filter condition. Let's say I will say filter where location equal to India, then it will give you only India data. Okay, that push down filter, what it will do on the file itself, it will on the file itself when it is reading, it will query that and it will read only the India data. So this is very, very advantage when you have a huge data. Okay, when you're dealing with the huge data, you need to push down, you need to apply push down filters. So what these push down filters will do is all necessary data, everything only will be scanned, all remaining data it will not scan. Okay, you see here what is happening. File scan CSV, basically it is scanning your data. It is basically scanning your data. It is reading your data. Okay, you can see here also file CSV. But what is this? Store location ID, store profit. Store location ID, store profit. See why it is not reading all the columns. Okay, why it is not reading all the columns from the stores table. In stores table we have store name and other things, but why it is not reading all those things? You see, from the stores data it is reading only store profit and store location, because end of the day in the transformation, if you remember, you see we are using basically store location and store profit only. Okay, but okay, fine, that is fine. Store profit and the store location we are having in the result, but why it is taking store location ID? Tell me. Yes, store location ID we have in the join. That's why store location ID it is scanning, but it is not scanning all the data. Did you understand? Whatever theory I have explained for that supporting document, practically supporting document, you understood? So it is scanning only the required columns, it's not scanning all the columns. That is the first thing. Next thing is not null, because if the store location ID is null, you can't join. We already discussed null can be joined with null. So let's say left table I have a null store location ID, right table I have location ID is null. When I apply inner join, both are matching, right? Matching or not matching?
Not matching.
Null matching, right? 1 matching, null matching, right?
No.
Okay, null will not match. Remember, in interview also many people will ask this question. I have given all the scenario based join queries, all these things we discussed. Okay, so is not null means it is making sure that location ID, where location ID should not be a null, so it is just filtering out wherever we have a null, it is ignoring is not null data only, it is taking, it is applying automatically filter which is required. You have not applied filter, but Spark knows what filter it has to apply, so it applied automatically. See here also filter is applied, filter is applied. Now if you see here, you have a location ID here. So location ID here. What is happening in this? If you see broadcast hash join of this particular, which one? Store data and what is this? This is a location data, both with the inner join you are joining. Okay. 1 second. I think what is happening here is, so broadcast hash join here its inner join is happening. So inner join is happening with which table? This table. But there is a one step is there here. In between there is one step. What this step is doing? You see here something like casting. So list of casting this particular column into which type begin, meaning location ID field, it is basically 0th index column. Okay, see from this list of columns, first index column, that is store location ID column, it is basically converting into the begin. Okay, so this particular that particular typecasting is happening. After that, the joining is happening. Okay, the joining is happening. After join, see, it is selecting only the two columns. The join key also we ignored, that's why it's not considering that. So what it is doing is, it is basically selecting only store profit and store location. Okay, after that, as you know, hash aggregations, so we are basically applying the sum of store profit. Okay, so exchange hash partitions, meaning simply like once when it is doing the aggregation is a Y transformation or not? Yes. So when you apply this sum, so this particular hash aggregate to happen, this hash aggregate, some kind of a exchange hash partitioning. So whatever partitioning data you have, that partitionings data will be exchanged to get this particular aggregated result. Okay, so these are the things happens. So finally, it is basically with this result. Okay, after exchange of the data to get a, see, for India data, we already given in multiple example. In partition 1 and partition 2, if you have an India record, when you do a group by, so all India records should come to the one partition. That's why there will be exchange in that. Similar to our join, there is a exchange. Okay, when you apply the aggregate function, then that exchange, see, the sum of merge of this particular sum of profit, sum of store profit. So and store location, basically based on store location, it is doing the sum of the store profit when it has done, and it is basically showing the result. Okay, there is something called adaptive Spark plan is final plan equal to false. What it means, adaptive query execution. So adaptive query execution is also one more technique which is automatically applied on our data when data should be cached, when our data, how many partitions should create. Okay, what should be the partition size. So most of the things will be taken care by the adaptive query execution automatically. Okay, so we will talk about this adaptive query execution in the upcoming sessions. Okay, clear till here, all of you clear? This is only physical plan, what is executed, but I want to see completely what happened. So what is unresolved logical plan, everything. See here, see, this is called a physical plan. Here we are calling this as an optimized logical plan. Here this is called an analyzed logical plan. Here we will call it as a parse logical plan. See, this is not unresolved. Okay, here it is showing as a parse, something like that, but these are the different names, that's all. These are the different names, that's all. Clear? Okay, so in the parse logical plan, what it is doing, you just check here. So in parse logical, one second. So in parse logical plan, what it is going to do is projection. So it is going to make sure, it is going to check store ID is there, name is there, store open here, store location ID, store owner, store profit, store location ID, store location. Okay, so all this particular projection, it is basically checking everything is available or not. Okay, then you can see basically subquery alias location, subquery alias store, meaning this is the store data frame, this is the location data frame. In location data frame, these two, we have these two columns. In store data frame, we have these columns. We are also applying the inner join based on the location ID. Okay, then we are also doing some kind of a check when location ID equal to US, then closed, else we are saying it's a active. Okay, the column name we are saying it as a is closed. So basically we have all these columns. Okay, all these columns in these two data frames, and our joining column is this location ID. So what it is doing is, so all the columns that we have between these two files, it has taken here. It is going to validate whether all these things are available. And the next thing is sum of store profit. The store profit must be a integer column. See, some of the names we can't do, some of the names it's a that cannot be done, right? So such type of things also it is going to validate. So that is what it is going to validate in the parse logical plan. So simply I'll explain once again. Location columns, it is scanned. Okay, store columns, it's scanned. Inner join keys also it's scanned, and it is just checking what columns we are deriving. All these things it just summarized here. All the columns it is going to check whether all these things are available or not, and also it is going to check store profit. We applied some, so store and profit, store profit, some function we can able to apply or not. Everything it is going to validate. After that, we have a analyze logical plan. In analyze logical plan, what we will have? Store location string. See here, the data types it is showing clearly. Store location is string. Sum of store profit which we begin. Okay. Again, same. Scan these columns, join keys. Okay. Then you derive these things, and basically, yeah, same thing is whatever you see in unresolved logical plan. It is just summarizing the columns and names, but making sure whatever columns are going to be displayed in the end result, those are having the proper data types or not. It is going to check. See, sum of store profit is showing as a begin. Store location is showing as a string, meaning it is going to validate whether these are correct or not. These are correct values or not. It is just validating. Clear? Cleared all of you? Next. Optimize the logical plan. Okay, so in optimize the logical plan, what is going to happen? You can see automatically. So first, when it is scanned, it is applying filter not null. When it's scanned, it is applying filter not null. But filter not null is you have not mentioned. That is the optimization technique. Instead of taking nulls and putting in the join, we don't require those null values in the join. So that is filtering out here itself. Okay, then after filtering, what other optimization it is doing? It is not taking all the columns. Instead, it is taking only these two columns. Instead, it is taking only these two columns. Then it is joining based on these two location IDs from store and store location. Then it is projecting the profit and location. From the profit and location, you can able to do the sum of store profit by location. Okay, just it optimized all filters it applied before you join, and also before you join it has taken what columns you need instead of moving all the columns to you, isn't it? So all this optimization is done, and we just have discussed about this physical plan. Cleared all of you? All of you clear? Very important. Next. So explain mode equal to simple. Simple is the default one. So when we have not given anything, only physical plan is displayed, right? Like that, only physical plan will come. So when you say extended, extended is nothing but whatever we have seen, all the four will display. Unresolved, resolved, optimized logical plan, and physical plan will be displayed. That's all. So these are the two things which are very important. And if you are initially, if you're learning, okay, you are just started learning the Spark, these are the good for you to understand the things, because it will tell you the numbering, which one is happening, what time. Okay, see, first scanning the CSV file, second filtering the CS that particular data, like is not null, so that location ID, right? So that is happening. Then broadcast exchange, basically it is what broadcast exchange is. It is basically taking only the required fields instead of taking all the fields. Okay, similarly it is scanning the CSV file and it is filtering the not null. Then it is basically doing the join. After join again, so store location ID we don't require, we need only store location and the store profit. So again it is doing the projection and then aggregations. So after to do the aggregation, we need again exchange of the data. Once the data is shuffled, okay, so all India data come to the one partition, then again it will apply the hash aggregation. Then it will try to check any like how many partitions it should be created, whether this result should be cached or not. Some more optimization will be taken care by this adaptive query execution at the last. Okay, you can see scan CSV1, what is happening in first. in filter 2. See, you can also see that is what I mentioned, right? Is null, is not null of store location ID. Broadcast exchange. What is happening? The required typecasting is happening here. Required typecasting and required typecasting is happening. Then scan CSV. So again, this is a store location table. We scan, we filter, broadcast join based on left key and the right key join condition. It's basically inner join. That's what is showing none. Then like these are the output columns, but all these are the input columns I have, out of which I'm taking only these columns out in the projection hash aggregation. So it will be step by step. It will be very easy for you to understand. Okay, so try to use a mode equal to formatted. It will be very easy. Okay, let's say mode equal to cost. You can guess it. What is cost? Cost means, can you tell me? Cost estimation. Okay, how much data we are scanning in each step, you can see. So size in bytes, 69 bytes, 236 bytes, 47 bytes. Okay, 253 bytes, 203 bytes. You can able to see how much data is exchanging in each plan. Okay, clear? That's all, friends. Any questions? If you have any questions, let me know. Okay, if no questions, then thank you. That's all for today.